Hi, this instructional video is about radicals. Simplifying radicals, that is. So, for example, on number 1, square root of 44. If I use a calculator, which would be so nice, if I said square root of, shift square root of 44, it'll give me some real number. 6.633 blah blah blah. So 6.6 something. Okay, between 6 and 7. But in algebra, during the computation, you get a chance to simplify numbers, reducing numbers that is. And if they're in a simplified form, it makes it easier to do that. So for example, square root of 44. Well, isn't square root of 44 like saying square root of 4 times 11? And I know what a square root of 4 is. It's 2. So it comes out. Whee! 11 is a prime number. It cannot be square rooted. So the final answer in this example becomes 2 square root of 11. And that becomes a simplified form of this radical expression. Why don't you try number 2 and 3? Okay, so this one you said square root of 63 is square root of 7 times 9. I know what a square root of 9 is. It's 3. So it comes out, whee! 7 is a prime number. It cannot be square rooted. So your final answer becomes 3 square root of 7. Yeah, and then number 3, you said square root of 90 is like saying square root of 9 times 10. Square root of 9, that's a 3. Whee! Square root of 10? Well, 10 is a composite number made out of 2 and 5, but they are not alike, so it doesn't do any good to break it down. So your answer becomes 3 square root of 10. Not too bad, huh? Then how about number 4, 5, and 6? Now, some kids, they get tempted to simplify 4 and 16, and they say, well, that's like saying 1 over 4. Well, yeah, that's good, but in order to encourage simplifying the radical expression, what I recommend for students to do is write that as 2 separate radicals, square root of 4 over square root of 16. Because when you evaluate, square root of 4 is 2. Over square root of 16 is 4, which reduces to 1 over 2. But this way, later on, when you simplify a more complex expression, you'll get a chance to simplify the coefficients. In this case, it's 1/2. Then how about this guy then? Yeah, you'll realize that 7 and 9 do not reduce. So in this case, you have no choice but to do it the way I did on number 4, which is to write 2 separate radicals, square root of 7 over square root of 9. Now, I know what a square root of 9 is. That's simply a 3. Square root of 7 cannot be simplified, so it stays as a square root of 7. And in this case, that's the most simplified form. Then this one? Yeah, now that you realize, you said, well, in this case, square root of 10 cannot be simplified, so it's still square root of 10. But square root of 162, let's see. Let's do a factorization, prime factorization. Let's see, 162. 2 goes into 162 81 times. And, ooh! So that's like saying square root of 2 times 81. But isn't square root of 81 a 9? So you get square root of 10 over 9 square root of 2. 2 cannot be simplified, so it stays inside the radical. Now here's the cool thing. That can be rewritten as 9. Oh, I'm sorry. It can be rewritten as, darn it, let me do it this way. Let me do it this way. Here we go. 1 over 9 times the square root of 10 over 2. Since 10 is inside a radical and 2 is inside a radical, I could put them in as a quotient. And when you do that, this time, 2 can reduce to 10 5 times. So the final answer, 1 over 9 times the square root of 5. That's not too exciting, but that's a good answer. Finally, how about over here? Now, 360. Isn't that like saying 6 times 60? And 60 is like saying 6 times 10. Oh, what are you doing, man? What I'm doing is I'm taking the 360 and doing the prime factorization. And so, in fact, what this is saying is negative 1/2 times the square root of 6 times 6 times 10, or 36 times 10. So 6 has come out, and here's what we get. Whatever comes out multiplies with the number outside already. The 10 does not come out. 1/2 of 6 is 3, so negative 3 square root of 10. There's your answer for number 7. This is getting pathetic. Whatever problem we had before, turns out it was not a very good question for our lesson. So here's a new number 8. 2 times the square root of 18. You try that one. Alright. So here's what we have. It turns out square root of 18 is like saying 2 times the square root of 9 times 2. Because 9 times 2 is 18. And I know what a square root of 9 is. It comes out as a 3. Whee! 2 is stuck inside. So the number 3 comes out, multiplies with the coefficient 2, so you get 6 square root of 2. And that's the final answer for number 8, the modified one. And number 9. So you said 63 square rooted is simply 1/3 times the square root of 9 times 7. Because 9 times 7 is 63. And I know what a square root of 9 is. Square root of 9 is 3, so it comes out. Whee! Who stays inside the radical is a 7. So what you get is 1/3 times the number that just came out, which is 3, times the square root of 7, who cannot be further simplified. But 1/3 of 3 is simply 1. Or just simply square root of 7 is the final answer for number 9.